Good day from Chem Help ASAP. In this video we'll name alkenes and alcohols and even throw in a couple alkynes. For the most part we will follow IUPAC nomenclature rules. There are multiple slightly different nomenclature styles that you will encounter. Always follow the style of your instructor since he or she is the one evaluating you. Go to the description of this video to find links to printable copies of these problems as well as printable solutions. This video also contains links to other videos that might help you with this material. Before jumping into the problems, let's just review a couple ideas about naming molecules. So on the left we have a category here, rules for naming alkanes. And alkanes are kind of easy. You simply find your longest chain. That's your first step. And then you go through steps, you figure out how you're going to number your chain, and then you add your substituents accordingly. With alkenes and alcohols and alkynes, it's a little bit different. The first step is actually to find your priority group. Now, your priority group is your highest priority functional group. We now have more functional groups in our molecule. And as it turns out, the title of this slide gives a ranking of functional groups. Alcohols, of the functional groups we're going to talk about, alcohols are the highest priority functional groups. And after alcohols come the alkenes and then the alkynes. So when we do these problems, we're going to have to find our highest priority functional group. And so then once we find the highest priority functional group, we're going to find the longest chain with the priority group. And then we'll number the chain, and then we'll add the substituents. So our first step is to figure out what is the key functional group for the molecule. And then we can start following our usual steps that we saw with alkanes instead. Problem number 1. So we can see in the upper left corner, here's our problem. What is our highest priority functional group? Well, it's going to be this alkene. So we're going to want to consider the alkene as a highest priority functional group. So we want to find the longest carbon chain that contains the alkene. And it turns out we can find a 6-carbon chain. Now we're going to number this chain so that the alkene gets as low a number as possible. So we'll start at the end. 1, 2, 3, 4, 5, 6. Fantastic. So this is a 6-carbon chain. We normally say a 6-carbon chain is a hexane, but since it contains an alkene, this is going to be some kind of hexene. And we can see there is a substituent. There is a methyl group at the 5 position. So now, how do we give the number for this alkene? The alkene resides on carbons 1 and 2. Well, we're not going to give both of those numbers. We're just going to give the lower of those two numbers. So this is going to be a 1 hexene. What does the 1 refer to? The 1 refers to where in the hex chain our alkene is located. So let's write this full name. 5-methyl 1-hexene. Now, a quick comment on style. It's become somewhat popular, I would say not universal, that people take the 1 for the hexene and they actually stick it right in front of the ene suffix. So this is another style. Watch your instructor and use the style that your instructor prefers. I tend to use the top style, but it doesn't matter what I use. You want to follow the style that your instructor uses. But it's really easy to switch between styles, but you need to be aware when you're absorbing different styles. So you can either put the 1 in front of the name or insert the 1 into the name, the hexene name. So that's problem number 1. All right, problem number 2. So again, we have an alkene in our chain. That's the only priority group that we have, so we're going to number this according to the alkene, and we want the alkene to get as low a number as possible in the chain. So this like the previous example is going to be a hexene, we could have tried to number the chain a little bit differently. We could have tried going down this different branch, but that would have also been a 6-atom chain. So it's really the same thing. So this is going to be some kind of hexene. It's going to be a 1 hexene. And off the 3 position of our chain, we have an ethyl group. So this would be 3 ethyl, 1 hexene, and your instructor might write instead hex 1ene. Now, one thing to note, if we didn't take into account the priority group needing to be part of the chain, we might have numbered this differently. And let's pick a different color. Let's go purple. We might have said, oh, there's a longer chain. 1, 2, 3, 4, 5, 6, 7. So we might have said, let's just find the longest chain that we can. And we would have found that there is a heptane. But when there's a higher priority group, we find the longest chain that contains a priority group. This heptane does not include our priority group, our alkene. So be mindful of where your priority group is and find the longest chain that contains that priority group. For our next problem, we again have an alkene, and the alkene is our top priority group. We will find the longest chain that contains this alkene. Turns out that's just 5 carbons. And we'll number so that the alkene is closest to the 1 carbon. That's easy because the alkene's on the end. So this will be some type of 1 pentene. Now on the 5 position, we've got a bunch of stuff going on. We have 5 fluorine atoms. So this is 5, 5, 5 trifluoro. So when we put this all together, we get 5, 5, 5 trifluoro 1 pentene. Now the reason I included this problem is because as a student you might think, well, certainly those 3 fluorines are more important than the alkene. So we should make that fluorinated carbon position 1, which would put the alkene all the way on carbon 4. But no, it's not about whether you have more of one group or that sort of thing. It's just the alkene is the top priority group. It comes ahead of alkyl groups and halo groups. So we number according to the alkene, even though there's just one alkene, and the halogens just land where they end up. And in this case, the fluorines end up at carbon 5. So just follow the rules, find your top priority group, and that top priority group will determine the chain and its numbering. Problem 4 is just a little bit different. We don't have an alkene, we have an alkyne. So that is our top priority group. Now, I'm going to go to the upper right corner. Alkynes, for some reason, are kind of confusing for many students. So it's very clear what's happening in that structure, but an alkyne drawn as a simple line angle structure would be written like that. That's a carbon and that's a carbon. And people may or may not put in the hydrogen. You can see on the left, I have not put on the hydrogen. We can add it in. But just be careful with counting your carbons with alkynes. So for this alkyne, we'll find the longest chain that contains our alkyne. And we can get this. And so we have 2 substituents coming off of here. Let's first write down our structure. So this is going to be the 5-carbon chain. It's not a pentane, it's a pentyne. And the alkyne is at the 1 position. So this is a pentyne. We have 2 substituents. We have in the 3 position a cyclopropyl, and in the 4 position a methyl. Let's put this together. So we'll put the cyclopropyl first because alphabetically it comes first with the C. And remember, with the cyclos, we count the C, the cyclo, as part of the name. So we don't alphabetize cyclopropyl as a P, it's a C. And C becomes before the M of methyl, and then 1-pentyne. Again, some people would not say 1-pentyne, they'd say pent-1-ine. That's a different style. But here's the name of this compound. It's a 1-pentyne. Again, pent with alkynes. Be careful with your carbons. This is a common mistake that new students make. They slightly misread these line angle structures that contain alkynes. All right, problem 5. We're actually starting to mix it up a little bit. We have 2 priority functional groups. We have an alkene and we have an alkyne. So, which one of these is higher priority? Well, alkenes take priority over alkynes. Personally, I like the triple bond to be higher priority, but it doesn't matter what I want. The alkene is higher priority. So we're going to number this chain so that the alkene gets the lowest numbers possible. So that's 1, 2, 3, 4, 5, 6. Now, how do we take care and name this molecule? Because it contains an alkene and an alkyne, and both those kind of get stuck at the end of the name. Here's what we're going to do. These are called ene-ines. So we're going to say this is a 1-hexene, and now we have to slip in between the ene and the ine the number, the position of the alkyne. And that's it. So, and in the 4 position, we have a 4-methyl. So what is our name? It's 4-methyl 1-hexene 5-ine. Now, if your instructor follows this style where you stick the numbers right in front of the functional group at the end of the name, you'd say 4-methyl hex 1-ene 5-ine. But again, I tend to stick with this style, but always follow the style of your instructor. The real message of this problem is alkenes have higher priority than alkynes. So the alkenes are going to control the numbering of the chain. Now in problem 6 in the upper left, we have added an alcohol to the picture. So we have an alcohol and an alkene. Those are the 2 functional groups we need to consider. Alcohols are higher priority. So we're going to try to find the longest chain that contains the alcohol. So the alcohol, as it turns out, is on the end of a chain. So we'll say 1, 2, 3, 4, 5. The longest chain we get is 5 carbons. It includes the alkene. So this is going to be, it's not a pentane, it's actually going to be a pentene. And the way we bring in an alcohol is we put in the OL suffix. So this is going to be a penteneol. Now for this, with the alkene, the lowest number of the alkene is 4. So we'll say it's a 4-pentene, but we still have to give a number for the alcohol, and we'll stick it right in front of the alcohol. 4-pentene-1-ol. We have 2 substituents. At the 2 position, we have an ethyl, and at the 3 position, we have a methyl. Now let's just put it all together. Alphabetize our substituents. Ethyl comes before methyl. That looks good. And now 4-pentene-1-ol. And again, if your instructor uses a different style, they might write this as pent. They'll put the number right before the alkene. Pent-4-ene-1-ol. So this problem shows that alcohols are higher in priority than alkenes, and so therefore when we find our longest chain containing the alcohol, we number to get the alcohol at the lowest numbered end as possible. All right, this problem has a little bit of a twist because it has a ring. So again, we need to look at our groups and find the highest priority group, or the higher priority group. In this case, the alcohol is higher priority than the alkene. Now this is going to be some type of six-membered ring, and it's going to be a cyclohexane. We'll need to add some suffixes to this, but the alcohol is going to be the priority position in the hexane, cyclohexane. So it will be in the 1 position. And now we're going to number around so we hit the next functional group as soon as possible. So we'll number in a clockwise manner so the alkene gets the 2 position. Okay, so this is going to be some kind of 2 cyclohexene, and the 2 is referring to the ene, the position of the alkene. How about the alcohol? It's very tempting to say, oh, it's 1-all. But in a cyclohexanol, the alcohol by default must be the 1 position because it's the highest priority group in the ring. So we actually don't need to say where the alcohol is because it's understood that has to be the top priority group. So you only get away with leaving out the numbers like this when you have, almost always, when you have rings. And the highest priority functional group is by default at the 1 position. Okay, what are our substituents? We have 2 methyl groups, a 4,4 dimethyl. So this would be 4,4-dimethyl, 2 cyclohexene-all. And this is a little confusing. The 2 is referring to where the alkene is. The 2 is not referring to the alcohol because we know in a ring, since we have an alcohol, that's the highest priority functional group in the molecule, and that by default is in the 1 position. So rings are a little more confusing, but the fact is when you do IUPAC style numbering, IUPAC doesn't like to have redundant information. You exclude redundant information because by repeating things it can become confusing. So just leave out the extra information and only list exactly what is needed. So in this question we have 2 of the same priority functional group. We have 2 alcohols. So it's pretty clear we're going to start numbering this chain, which doesn't even have any branches. We're going to number this on the left because both those alcohols can't be at carbon 1. So we'll number at the end of the chain, 2, 3, 4, 5, 6. This is going to be some kind of hexane. Now, how do we get 2 alcohols? Well, this is going to, for 2 alcohols, we say it is a diol. And we're going to call this a hexane diol. So where are our diols? They're at 1 and 2. 1, 2, hexane diol. Now, if this were just a single alcohol, we'd say hexanol. We keep the E of the hexane because we're putting it up against a consonant, D. So sometimes we keep the E because it makes pronunciation of the name easier. This is honestly, it's a rule that it's not easy to learn, and it's something that you begin to appreciate as you hear people saying names over and over again. And these names tend to roll off your lips if you include that E for certain cases. Typically, we drop that E, but for when we put these consonants before we have these consonants on these infixes, we need to have that E in place. So we have only one substituent on our chain, and that's a 4-bromo. So writing our structure will be 4-bromo. Always start with the substituents. And now here's the molecule. 1, 2, hexane diol. And there's our name for problem number 8. I hope you found this video helpful. Please subscribe, like, or leave a comment or question. If there are different types of problems you'd like to see in future videos, absolutely please let me know. Thank you for watching, and remember that links to printable copies of these problems and solutions are in the video description. Take care.